Good morning, guys. Today we are going to start a new series that is on medicinal chemistry. To tell you something about medicinal chemistry is not just a study of all the structures and the SAR, that is the structural activity relationship, but in our course we will try to go from the basics and then we will try to step up to structures and their structural activity relationships. So today we will learn about the basics of nomenclature and structures. So let's get started. First we will learn about the common functional groups. Now if we learn about like what is an acid chloride. Now if we learn what is an acid. Acid is carboxylic acid R C double bond O and OH. Now if we say acid chloride, OH will be substituted with chlorine, that is Cl. Alcohol is written as ROH. Aldehyde R C double bond O and H. Alkene R H. Alkene would be C double bond C and the two other groups attached to each carbon. Alkyl halide would be written as R, which is any alkyl group along with the halogen group. That is, halogen group will be marked as X. Now the halogen groups which we can include are chlorine, bromine, fluorine, iodine. Now if we look at alkyne, alkyne would be C triple bond C. Amide, amide would be written as R C double bond O NH 2. Amine will be written as R with an NH2 attached directly. Now what's the difference between amide and amine? Amide would be there is an extra C double bond O, whereas an amine will not have that C double bond O. Now how do you remember amide and amine and what's the difference? Mine, just remember mine. If it's yours, you will try to keep it very simple. But if you're giving it to someone, you will want it to be a little extraordinary. So a mine would be, that is mine. So it is directly attached to me. So it's attached to the R group. So R NH2. Whereas amide, since I'm giving it to someone else, it will be R C double bond O. Then there would be an attachment of NH2. Now anhydride. I want to tell you a story of what is anhydride. Now anywhere if there is the presence of this word an means there is something is missing. Something is missing and hydride. Hydride means H2O. Now if we take carboxylic acid, that is R C double bond O OH. Two carboxylic acids. So again another R C double bond O OH. Now if we remove water from this, we will get R C double bond O O C double bond O R, which is a acid anhydride. Anhydride as in the removal of water. Okay, so now let us see how do we write a aromatic compound. A aromatic compound will be written as a benzene ring or any aromatic ring which has like an alternating double bond pattern. Then for an carboxylic acid, we will have R C double bond O OH. For an ester, since we have E and T which is separated by an S, we will have R with a C double bond O extra and then continued with an OR. For an ether, we have E and T which is very close to each other. So R will be attached to OR. For a ketone, we have R C double bond O R. For a nitrile, we will have C triple bond N, and to complete the valency, another bond over here. For a sulfide, we will have R S R. For thiol, we will have R S H. Now if you notice, thiol is like an alcohol. It has the OL. For an alcohol, we will use OH. But for a thiol, since thi is sulfur, we will substitute this S with the electronegative element oxygen. So thiol will be given as RSH. Now for a thioester, thio and an ester. Ester is usually written as R C double bond O OR. Now since it's a thioester, we will substitute sulfur for this electronegative element of oxygen. So R C double bond O S R is a thioester. Now let us move on to the nomenclature of certain benzene derivatives. Now if it's a mono-substituted benzene, that means there is one substitution in the benzene, we will add the name benzene with the one substituent. So the substituent name will be added to the word benzene. Now for example, if we have this ethyl group, we will name it as ethyl benzene. If we have a tertiary butyl group, we will name it as tertiary butyl benzene. If it's a chloro group, we will name it chlorobenzene. Now, for a di-substituted benzene, di means 2. If there are 2 substitutions, we will have to add the prefix ortho meta para. Now, what is this prefix ortho meta para? In a benzene ring, if we consider a substituent to be present over here, we will name the remaining positions according to its distance from the substituent. Now, if it is just adjacent to the substituent group, we call it the ortho position on both the sides. The one which is alternating to the substituent group, we will name it as meta position. And the one which is directly opposite to the substituent group, we will name it as the para position. Now, according to this, we will consider one of them to be the substituent group. If we consider this bromine to be a substituent group, this bromine will be in the ortho position. So we can name this group as ortho. Since there are 2 bromines, we will call it as ortho dibromobenzene. Or we can give it numbers 1, 2. So we will have 1, 2 dibromobenzene. If it's in this one, if we consider this one the substitute for a change, we will name this as ortho meta. So we will name this group as meta dibromobenzene. Or if we number it 1, 2, 3, we will name it as 1, 3 dibromobenzene. Now here is a trick for you. How do we name this one? Since one is bromine, one is chlorine. So we give the lowest numbering to the substituent with the first alphabet in the first alphabet or the lowest alphabet. So we have a bromine and a chlorine. So bromo, chloro. So B is the lesser letter as compared to C. So we will take B first. We will name B as 1, or we will take this as the main substituent. Then we will name ortho as chloro as the ortho position. So we have ortho. Since between B and C, bromo has the lowest letter, we will name it as ortho bromo chlorobenzene, or we can also name it as 1 bromo 2 chlorobenzene. Next we will go for polysubstituted. Poly means greater than 2 substitutions in the benzene. If this has to be named, we will give a number first, and the number has to be the lowest possible number around the ring. And second is, we have to check the alphabetize the substituent names and then check. Since 2 carbon is named as ethyl, 3 carbon is propyl, 1 chlorine would be named as chloro. So if we check the alphabetical order, E, C, E, P. So C is the lowest, then E, and then P. So according to this, if we give the numbering around the ring as 1, 2, 3, 4, we will get 1, 2 and 4 as the substituent numbers. If I don't want this, I want to challenge the system, I will name it as 1, 2, 3, 4. What can go wrong here? We will check here. Our substituents got the numbers 1, 3 and 4. Now we need to check the sum of the substituents. So this is 1 plus 2, 3, 3 plus 4, 7. 1 plus 3, 4, 4 plus 4, 8. So we need to give the lowest possible number. So this is 7. So we need to go with the black one. So we will name this as, first will be the chloro group. So 4 chloro, 1 ethyl, 3 propyl, and this is the benzene. So benzene. Now if we check this group, there is a amine group and there are 2 chlorine groups. But there are some rings, some benzene derivatives which have common names. Now for example, this benzene ring with the amine group, the common name is aniline. So we can use this common name as well. So this name would be 2,5 dichloroaniline. Now next is naming an aromatic ring as a substituent. If it's a substituent, there are two things we can write for a benzene ring. We can either call it a benzyl or a phenyl. Now what is the difference between a benzyl and a phenyl? A benzyl can be a ring can be named benzyl only when the benzene ring is attached to a CH2 group, an extra CH2 group, whereas it's called a phenyl when it is attached directly to the next thing which we have in mind. Now, so the only difference is the CH2 group. If the CH2 is present, it's a benzyl. If it's not present, if it's a phenyl. Now for this ring, since a carbon is attached, it would be methyl benzene. Whereas here there is no carbon, so we will call it a phenol. Alcohol here, alcohol group will be named OL. So phenyl plus OH, so phenol. Now there are some common benzene derivatives which have some common names which we can use as the root name. So first we had seen about phenol. Now we have toluene. Now toluene is methyl benzene. Now why is it called toluene? Actually it is called toluene because it is derived from the tolu of balsam. So we call it toluene. Since the carbon is directly attached, it will be a benzene. So methyl benzene is also known as toluene. Aniline. Now since this group is an amine, we take the name from the amine. So A from the amine and Ni. So aniline. Now anisole. Anisole is methoxybenzene. Since it's methoxy, we will call it as anisole. This is the common name. Now acetophenone. Acetophenone, if we take this group, we have two carbon ring here and we have a benzene ring alone over here. So what is the common name for ethyl? The common name for ethyl is acetyl. So we will name this one as acetyl. A carbon ring with no a benzene ring attached with no carbon is known as a phenyl. So acetyl phenone, since it's a ketone group. Next we have a benzaldehyde. Since it is a benzene attached with a CHO group, we will name it as benzaldehyde. Since it's a benzene attached with a COOH group, we will name it as benzoic acid. Next we have some heterocyclic compounds. So these will be the basic or the kind of bricks for your building. So since you need to draw some very complex structures, these heterocyclic compounds will help you. There will be some clues in the name of the compound which will state which heterocyclic compound it belongs to. So let us see some common 5-membered ring heterocyclic compounds. Now if it's a 5-membered ring with a oxygen at the tip, we call it a furan. Please remember, a 5-membered ring with oxygen at the tip is known as a furan. If we have a 5-membered ring with an NH group attached to it at the tip, we call it a pyrrole. So furan, pyrrole. If it's a sulfur attached to the tip of a 5-membered ring, we call it a thiophene. Next we have some 5-membered di-substituted rings. Now there are 2 substitutions in the rings. So if there are any 2 substitutions in the rings, the ending will always be ol, O-L-E. So let us also remember some easy tricks here. If it's a O, it will always be named as ox. If it's an S, always thio. If it's a N, us. So let us try naming this compound. If it's a 5-carbon ring with 2 nitrogen attached adjacent to each other, we will call it a pyrazole. Now if we had only 1 nitrogen ring, remember we called it pyrrole. If it's a 5-membered ring with 2 adjacent ones, we'll call it a pyrazole. A single nitrogen would be pyr, and since it's another nitrogen, we will name it as pyrazole. Now if it is 2 nitrogens which are alternating to each other, we will call it imidazole. If it's an oxygen and a nitrogen contained in a six-membered ring, which is like alternate to each other, we will call it oxygen is ox, nitrogen is us, so ox us, and ol, ending ol, oxazole. If it's a sulfur and a nitrogen attached alternatively in a five-membered ring with two double bonds, we will name it as thiazole. If there are three nitrogen groups attached in a five-membered ring with two double bonds, now since it's 3 and nitrogen, 3 is called tri, and for nitrogens we have given the name us, plus we have to add an ol everywhere because it's a five-membered ring with two double bonds, we will name it as triazole. Then if it's a four nitrogen ring five-membered ring, we will name it as 4 nitrogen, and then we have a five-membered two double bond containing ring, we will call it 4 is tetra, nitrogen is us, five-membered ring with two double bonds is ol, so we will get tetrazole. I hope this trick is useful. Next we have six-membered rings. Now in the six-membered rings, it will either have the suffix or the prefix of PYR. Now in a single nitrogen containing ring, we will call it a pyridine. A six-membered ring with two double bonds and an oxygen, we will call it a pyran. Remember, a five-membered ring with an oxygen was named as furan. Since it's a six-membered ring, we said pyr will come everywhere in a six-membered ring. So we will have it as, instead of furan, we will have pyran. And since if it's a sulfur group at the tip of a six-membered ring with two double bonds, we will call it as a thiopyran. Sulfur is thio, so thiopyran. Next we have two nitrogen groups which are attached adjacent to each other in a six-membered ring. We will call it a pyridazine. A pyridazine. If it's two nitrogen groups attached alternating to each other, we will call it a pyrimidine. A pyrimidine. If it's two nitrogen groups which are attached opposite to each other, we will call it a pyrazine. Now let us see where we get the root names from. Pyridazine is any six-membered ring which has two adjacent nitrogens between two carbons. So between two carbons we have two adjacent nitrogens. It will be known as pyridazine. Pyrimidine, also known as 1,3-diazine or M-diazine. So we will name it as pyrimidine. If it's two nitrogens opposite to each other, the numbering would be 1, 2, 3, 4. So 1,4-diazine. So we will have two nitrogens as in its pyr, and then nitrogens is us and in. So diazine becomes pyrazine. So if we remember five-membered rings, if it is adjacent to each other, we will name it as pyrazole. This is for five nitrogen ring. If this is for a five-membered ring, if it's for a five-membered ring with two alternating nitrogens, we will call it a imidazole. Okay. Next we have a combination of 5 and 6 membered rings. Now here we draw the line here. Since it's a benzene plus a furan ring, we will call it a benzofuran. Since it's a benzene plus an imidazole ring, we will call it a benzimidazole. If it's a benzene along with a 5-membered ring with a nitrogen is known as pyrazole. So if a benzene is attached with a 5-membered ring with a nitrogen on the tip, we'll call it a indole. Then next we have pyrimidine. We had just stated just now what is a pyrimidine. It is two nitrogens attached alternatively. Then we have a purine. In a purine we can consider purine as a mixture of an imidazole along with a pyrimidine. So this is a pyrimidine and this is a imidazole. So the mixture of a pyrimidine and an imidazole will give you a purine. Now pyrimidine and purine are nucleotide bases. So next up we have carbazole. Carbazole is a mixture of two benzenes plus a pyrazole. Now a quinoline is a mixture of one benzene plus one pyridine. And then isoquinoline is just the nitrogen to be transferred from here to here. So if it's in this position, we will call it as isoquinoline. Otherwise, it will be in this position, it would be a quinoline ring. Next, I have a trick up my sleeve. So if there is a nitrogen containing 6-membered ring, and one more disclaimer, this only works when the nitrogens are opposite to each other. The two nitrogens are opposite to each other, or it is just one nitrogen. So if there are double bonds, we will call it a PYR, pyre. And if it's a single bond, we will call it a piper. Now how do you remember pyre and piper? Remember, I comes before Y. So I will be one bond, whereas Y would be double bond. Now next is one nitrogen is called idine and two nitrogens will be called azine. So one nitrogen is a D, two nitrogens is a Z. D comes before Z. So pyre, piper along with idine and azine. So piperadine. So how do we write a piperadine? Piper as in it's a single bond, idine as a single nitrogen. Piperazine, a single bond in all the structure, and azine is there are two nitrogens. Pyridine, it has double bonds, and idine as in it has one nitrogen. Pyrazine, double bond, azine, two nitrogens. So that was all we had for today. I hope you enjoyed the class. I hope you took a lot of tricks and how to remember the following structures. So we'll be back with such videos next week. So until then, please like the video, subscribe to our channel, and click the bell icon to get notified about the future videos. Thank you. Mogasu.